Alright class, today, me, Professor Bacchus, and behind the camera, Professor Zioko, will be going over improper integrals and the difference between convergence and divergence. So let's get started.
So class, we're going to start with the integral of 1 to infinity of 1 over x dx. How do you think you would be able to evaluate this integral? Is it going to be convergent or is it going to be divergent? Now, the difference between convergent and divergent is if it is convergent, then the limit is a finite number and it will converge on that one specific value. However, if it's divergent, it'll be a number like infinity where it can't converge on the one value. Now, we can realize that this is going to be an improper integral because you'll have infinity either in the lower or upper selection of the integral. So we're going to need to replace infinity with a variable. Let's just use q. So we can do the limit as q approaches infinity of 1 over q, 1 over x dx. First, we'll be taking the antiderivative of 1 over x, and obviously we all know that to be ln x. So we'll do ln x, and we're going to evaluate that from 1 to q. So now, with the next step, we're just going to evaluate it. And so we're just going to replace x with q, and then we're going to replace x with 1. So now we can rewrite that as equaling the limit as q approaches infinity, ln q, minus the limit as q approaches infinity, ln 1. Obviously, we all know ln 1 is equal to 0, so we can cancel that out, and we are left with the limit as q approaches infinity, ln q, and we can just evaluate this as to be equaling to infinity. Therefore, this is not a finite number, and our answer is going to be, it is divergent.
What's going on, guys? Back with another banger. Professor Travi Patty here. Today we're going to be looking at another example of topic 6.13, defining improper integrals. So for our next example, we're going to be looking at the limit from 1 to infinity of 1 over x squared dx. Now, if you guys think you can do it for yourself, pause the video right here. All right, now for those of you who are too stupid to figure out for yourself, let's get started. So we're going to turn this into a limit expression. So once again, we're going to be using q. We'll take the limit as q approaches infinity, and then we'll take the integral from 1 to q of 1 over x squared dx. First thing, we're going to have to find the antiderivative of 1 over x squared. And to do that, we're just going to rewrite it so we have x back on top. So we're going to have x to the negative 2 dx. Now, using the power rule, we can add 1 to that, which is going to get us x to the negative 1, and then we're going to divide by negative 1, and then we'll have plus c. So if we rewrite it, we're going to get negative 1 over x plus c. All right, so to continue what we started previously, we're going to say that the limit as q approaches infinity for negative 1 over x, we're going to evaluate that from 1 to q. All right, so now we're going to evaluate it. So we're going to have the limit as q approaches infinity, and then that's going to be for negative 1 over q minus negative 1 over 1. All right, so now if we rewrite it again, just because we have negative 1 over 1, so we'll have the limit as q approaches infinity of negative 1 over q, and then we can just say plus 1 because it's minus negative 1. So if we look at the limit, it's as q approaches infinity. So infinity is going to be in the denominator here. And, as you divide something by like a larger quantity, it's going to get smaller and smaller. So we can say that negative 1 divided by infinity is going to equal 0. So we're just going to have 0 plus 1, which is going to get us 1. And because this is a finite number, the limit exists, that's going to make it convergent on that point.
That was it from Professor Baucus.
Professor Travi Patty.
We'll catch you in the next one.